Hey guys, welcome. Yeah, so I already made a video on basic practice, so if this feels hard, then you should start there. But otherwise, we had five basic practice problems, and so we have five harder practice problems. I might make one more set of five difficult practice problems. But yeah, anyway, with these five practice problems here on the right, actually with four of them, except for this start one, we have a composition of three functions. And of course, we can take a composition of three functions, say this, and make it a composition of four functions. But let's keep things simple and see them as they are, as they appear, which is as a composition of three functions here, composition of three functions here, three functions here, three functions here. Here we have a composition of two functions, but we also have the added difficulty of dealing with chain rule and product rule. So yeah, this is harder than the basic practice problems. This fourth one, even though it's only a composition of two functions. Anyway, we looks like need to know how to deal with chain rule when we've got a composition of three functions. So if y is made of three functions, say f of g of h of x, then chain rule would say that y prime, the derivative of y, is given by f prime of g of h of x, and then times g prime of h of x times h prime of x. And so you could imagine, how this would go if we had a composition of four functions. But yeah, basically if f is the outermost function and h is the innermost function and g is the middle function, y prime is like take the derivative of the outermost function, leave the other guys alone, and then move in, take the derivative of the middle function, leave the guy inside him alone, and then multiply by the derivative of the innermost function. Yeah? Okay, so in our first problem here, we've got y equals sine of tan of 2x. And so sine is f, tan is g, and 2x is h. So y prime, by what's written here, will be f prime, which is cosine, right? So cos, leave the other guys alone, so cos of tan of 2x, and then multiply by the derivative of g, leaving alone h inside of g prime, right? So anyway, since g is tan, its derivative, the derivative of tan is sec squared, and then leave what's inside alone, and that's h, and that's 2x. And then multiply this by the derivative of h, and h prime is the derivative of 2x, which is just 2. So I should multiply by 2 at the end, but proper math grammar tells me that I should write that 2 in front instead of multiplying by 2 at the end. I'm going to elect to do this instead. Ooh, got that? Okay, which is put the 2 in front, and that's proper math grammar, yeah. Okay, so there. I don't like that 2. That's better. Okay, there we are, and that's how we deal with the first one. Let's move on to the second one. So kind of business as usual, which is like E is F, and then cosecant is G, and then 5x is H, so y prime is going to be F prime, so the derivative of E is just E, and leave the other guys alone, so F prime of G of H of X to start, so that's cosecant of 5x, right? And then multiply this by the derivative of cosecant, leaving alone h inside it, right? So the derivative of cosecant is negative cosecant cotan. So that's quite a bit to write. So we need a negative. So let me put the negative in front here, a negative, and then it's cosecant cotan. You'll see why I left a little bit of room here. But again, negative cosecant cotan is the derivative of cosecant. But then, I need to leave h alone. So I've kept the 5x here and here. Yeah. Okay. And then now I need to multiply by the derivative of h. So that's h prime at the end. And since h is 5x, h prime is 5. And you see that I left a little bit of room here for the 5. Apparently not enough room. With that giant E next to it, I don't want to write a very tiny 5, so Yeah. How about this? This will do us good. Yeah? Okay, cool. We're done with the second one. On to the next one then. And the next one is this here. And secant is F. And then E is G. And then 2x is H. So F y prime is going to be F prime. So the derivative of secant is secant tan. So F prime, leave the other guys alone. Secant and then tan, right? So secant and then tan. Secant tan is the derivative of secant, but then we need to leave the other guys alone. So secant e to x tan e to 2x. Yeah? All right, cool. And then now we multiply this by the derivative of g, leaving alone h in it. G is e, so its derivative is just e, and we leave h alone, so that's 2x. And then the derivative of h is the derivative of 2x, that's 2. You would have thought that I'd learned from, yeah. Okay, anyway, I'm going to put the 2 in front. We already talked about that. That's proper math grammar, and so there we are. All right, now I'm going to skip to the last one because the last one is a composition of 3 functions, and this kind of, the start one, the fourth one is the unique one. So the last one, like, one thing you need to understand is that y can be rewritten as follows, which is y is cosine of sine x, right? O squared, right? Like when we put cosine squared, we mean actually cosine of sine of x O squared, right? So like get rid of that 2 there would require that we do this, right? That's what I'm doing. So then the outermost function f is actually x squared. It's in it that we plugged in g of h, which is cosine of sine, right? But yeah, the outermost function is actually x squared. So making that abundantly clear. And then the middle function is cosine, and the innermost function is sine. So now that you understand that, y prime will have to look like the following then, right? Y prime would have to be, well, the derivative of x squared is 2x, but it's not just 2x, it's 2 times, and then we leave the other guys alone, and that's cosine of sine x. And it doesn't make sense to write to the power of 1, right? For the 2x to the first power is the derivative of 2x. I'm just going to not do that, right? Okay, we move in. Now the derivative of cosine is negative sine, so I'll put the negative right there, and then the sine right there. But then, yeah, we need to leave h alone, and h is sine, so that's got like a weird, yeah. And then finally, the derivative of h, the derivative of sine is cosine, so we multiply by cos x. Now, very important here, it's not sine x times sine x, it's sine of sine x, right? Okay, cool. But otherwise, this is it for 4 of them. And the fifth one, this fourth guy here, is the interesting case. First, as I said, we have a composition of 2 functions, and the composition is between x squared and the function x times e to the x. So the function x times e to the x is plugged into the function x squared, and that's how we made this function, right? So the outer function is x squared, and the inner function is x times e to the x. And so this is chain rule when we've got like a composition of 2 functions. So that, just a quick reminder, is, I mean, you should know, but if you're watching this video, so that's y. And so what we're saying is y prime is f prime of g of x, and then times g prime of x, right? Okay, cool. So we only have an outer and inner function. So the derivative of the outer function, since it's x squared, is 2x, but again, we have 2, and then we leave g this time, which is x e to the x alone, so x e to the x, right? So I've got f prime of g of x and what I've just written right here, and now we need to do the derivative of g and in this case, which is the derivative of x times e to the x, and that's what's going to multiply this. And so we need to be careful because we know product rule like creates 2 terms. So I do this, and then now the product is between x and e to the x, and applying the product rule between x and e to the x, we know that we do the derivative of x, which is 1 times second function, right? So leave e to the x alone, and then plus leave x alone, and I'm just applying product rule, so you should know. And then the derivative of e to the x is just e to the x, so there we are. And yeah, so can we write y prime a bit more succinctly? I suppose yes, and we can do this. We can write e to the x and then squared, right? E to the x squared, or well, it's e to the x squared like this, right? It's e to the x here, and I can factor out e to the x from these guys. I can factor out e to the x from these two guys here, and so I multiply that to that, and I get this, which is the same as e to the 2x, right? What I had this here is the same as e to the 2x, but neither of them is the same as this. It's no good, right? This is what we had, and we can, if we so chose, write it like that using exponent rules, right? Okay, cool. So then what would I have to write after it? And I don't need square brackets because I only need one set of brackets. Okay, and after it, what do we have left? Well, we've got this and this guy taken care of, so we should have a 2x left, and a 2x, and then plus 2x squared, right? Yeah, okay, cool. So this guy, and then factoring out these guys combined into this, and then you've got a 2x, but it's multiplying both of these guys. So 2x multiplying 1 plus x is going to be 2x times 1, right? 2x times 1, that's 2x, and then 2x times x is 2x squared, yeah? Okay, actually, like, yeah, you could probably, like, do a little bit better by writing the 2 right here, but whatever, you get it. Okay, I'm done here. I hope you enjoyed this, and keep watching. Take care.